So word problems, they're contrived, and you know, nobody really does the kind of problems that you see that we have in word problems, but they're presumably simple enough and straightforward enough to get you to the point where when you see real life stuff in your physics or your chemistry class or your economics class or things like that, that you'll still have, you know, the ability to formulate these things. So they seem kind of awkward and they seem kind of unrealistic, but that's just, you know, essentially to give you some practice. So one thing you'll find, regardless of your profession, ultimately, is that nobody's going to come up to you and say, find X. And that really is the question that you've had most of the time in algebra, right? Somebody's going to ask you a real live question, and you're going to have to make it into a mathematical problem. So in addition to that, you usually have to show others how you get to a solution. So I don't think I've ever had it either as a manager or as an employee that I walked up to somebody who's asked me a question and say X equals 5. You know, usually you say something like, oh, we need 5 months to do this project, or this particular budget is $5,000 over, or you know, things of that sort. That you need to be able to answer the question, but then also substantiate this. And so just arriving at the answer is never the entire goal. Part of the goal is to be able to communicate how you got there, and then also do yourself a favor in that you frequently will do the same kind of problem over and over in any business or job that you're in, and so it'll be essentially a reminder on how you did it before, and so just changing around the numbers is all that's needed. So that's why I want to really emphasize, you know, working with this particular format. Okay. So the other thing that it allows you to do using this kind of method that we're going to talk about is that it allows you to solve a problem over the course of time. Almost always you'll have exactly the information you need when I give you a word problem. You know, give you all the data, sometimes give you a little bit too much. But in the real world, you're probably going to have to do some research and find certain numbers. And so when you set up a problem to do, you want to be able to stop and go back and maybe check a few numbers, you know, if something doesn't seem right. And so having a format for doing word problems, you know, allows you not to have to restart every time you leave the problem and do some research. So the other thing that's important is to be able to do your problem in a way that somebody else can see how you did it. Now, one of the things I like to say is that math is easy to follow and harder to do. So you may find that when I'm showing you how to do something, you think, oh yeah, that's pretty straightforward, and then you go to do it yourself, you find that it's actually a little bit more difficult. As you become experts in your field, people are going to look at you that way too and say, okay, here's a problem that this person solved, and so they can read right through it, and they may not have been able to do it themselves. So documentation around problem solving is really quite important. Okay, so we're going to look at 5 steps here, and step number 1 is gather your data and make a model. So let's have a question here, and I'll go through these steps and then I'll recap them at the end. So let's say you bought a sweater for 56 bucks and it says it was on sale for $30 off. What was the original price? Okay, not a convoluted question, a pretty straightforward question. So the thing that you want to do is you want to make a model, and whether you write it like this, and this is in the style that the book writes it, where they draw these boxes around it, you don't have to write it exactly this way, but before you actually get into the numbers, don't, you know, start solving the problem before you're ready. Write what essentially what the process is for in this case, discounting something, where you say, okay, you take an original price, you take a discount, and so you get a discounted price. All right, so when you do that, then you say, okay, what was my discount? My discount is the discounted rate and the original price. Okay, so if I'm going to have a $100 item and I take 20% off, my discount is going to be 20% of 100, which is just $20. Okay, so now I can make this substitution by saying, okay, my discount here is this, and so I can say my original price minus this right here will equal my discounted price. And so here I have my model that essentially sets up the relationship between the things that I know and the things that I don't know. And I'm not trying to set up any equation or anything like that. All I'm trying to do is get clear in my mind what the relationships are. Now, sometimes with a word problem, you don't write something like this that's necessarily a verbal model. Sometimes if it involves some geometry or something like that, you'll draw just a picture and you'll show, you'll dimension what you know, and you make some variables for things that you don't know. Okay, so this is copied from the previous page. This is exactly the bottom green thing that I had on the bottom. So step number 2 now is to define your variables. It's too easy to just start using variables, x equals. What you want to do is you want to define variables and define constants very carefully so you can put them into the equation properly. So the first thing, you just go through and you say, okay, original price, I don't know what it is, so I'm going to call that P. You can use X if you like, but I like to use variables that remind me what it's about. So P is a good symbol for price. Now, I know that the discount rate is 30%. Now, when you're dealing with percentages and you're calculating with them, you always put them in a decimal notation. So we have a discount rate of 30%, and we know that our original price is $56. Okay, not the original price, the discounted price. And you see, we have the original price is already defined as P, and so we have the discounted price. So what I've done here is I have a complete definition of my variables and the things that I know. And very importantly, I indicate that this is in dollars. Okay, so maybe with money it's easy because it's always in dollars, and maybe it's easier to do it in cents to eliminate decimals. You can do that. Or if you're dealing with something that involves some unit of measure, it's rare that everything works so conveniently that you don't ever have to do any unit conversions, like putting feet into inches or meters into yards, or any of those kinds of things. So using your units is a really important way to perhaps set this up so you have less calculation to do ultimately. So then step 3 now is to write your equations. I'm going to use the model that I made, the definitions that I have, and I'm just going to start substituting these things, and I'm going to write out an equation. And so what I get is P minus 0.3 P, that's a decimal, not a 1, 0.3 P equals 56. So now here I have an equation that I can solve. So that's step 3. So by step 3 now I have an equation. Everything is defined. All the variables here, I know exactly what they stand for. And so now we solve the equation. So my equation is P minus 0.3 P, and so what I'm going to do is I'm going to combine the two. This is 1 minus 0.3 is 0.7, so I got 0.7 P equals 56, and then divide both sides by 0.7, and that turns out to be 56 divided by 0.7. Well, it's easier to look at this as 560 divided by 7. And so you can do the math. That's not difficult. 560 divided by 7 is 80. So your original price is 80. So you're not done. All you know is that P equals 80. What you need to do now is you go back to the original question. Well, let's first check the math, and indeed, it all works out. So what you want to do is you want to reread the question, and you want to make sure the units are in the form that the question is asking, and then you answer the question. And here I'm going to insist that when you have a word problem that you actually write it out in natural English. So it says the sweater was originally priced at $80. So if I go back to, and here I'm just stepping back to the original question, you bought a sweater for $56, it was on sale for $30 off. What was the original price? And my answer then is the sweater originally was priced at $80. You see, you're answering in the same language that you're being asked. It's not just here's a formula, solve the formula. This is somebody asks you a plain English question, and you answer in plain English back. Okay? So those are the 5 steps. There's nothing really that fancy about it. I'll write them on the side here, so as we go you can kind of get them in your mind. So the first one is you want to gather your data, make your model or draw a sketch, any of those things, whatever's appropriate. Number 2 is define your variables. Three is write your equations. 4 is solve the equations, not write them, you've already written them. Solve the equation. And here's a good point where you check. You want to check your answers, make sure it makes mathematical sense. And then 5 is answer the question. So it's useful at this point to look at the question again, because it's quite well possible that when you set up your equations, let's say there's 2 things, like if it's a problem involving my age and my brother's age, and you find my age, but my brother's age is the question, it allows you to really answer the proper question. Sometimes you don't care about the width of something, you care about the height of something. And so if you just answered W equals, that's not really the answer to the question. Okay. You don't need to label the steps 1, 2, 3, 4, 5. Okay, but I will mark it if if you don't define your variables. I might write, what is x? I really do want you to do each of these steps. Step 1 can take many forms. This is where you kind of gather all the things out of either just the statement of the problem, or if you have to look something up, or gather your data in some other fashion. I really strongly recommend that you use convenient, easy to remember variables. If you always use x and y, by the time, if it's a complicated problem, ultimately you're going to forget what x is about. And if you use something like p for price, or n for the number of something, it kind of reminds you, especially if you have more than one variable, what all these things really mean. Okay, so for tests and quizzes, I'm going to score you mostly on process. If you give me a numeric answer only, even if it's something that is easily done in your head, you get less than 1/4 of the credit for the problem. Okay, so the flip side of that is if you do all these kinds of things and maybe you get a computation error, then 560 divided by 7, you get 70 instead of 80, you won't lose very much if you show the rest. Okay, because it's an easy problem then to fix if you have everything laid out properly. Okay, any questions on this process? All right, so sections 2.2 and 2.3 deal with making models for word problems. We're going to talk about percent, ratios, markup, and discount. Now, percentages tend to be a little confusing, so I want to take a few minutes and look at percentages a little bit, and hopefully this will be just a review for you. Okay, so if 80 changes to 100, if something that you have grows from 80 to 100, or if 100 declines down to 80, what's the percentage change? Okay, you think, okay, these are the same numbers. If I go up a certain amount, I'm going down by the same amount. The percentage change is different, and it's different because you have a different basis. And so if I add 20 to 100, I'm going 20 more than 80, and so I have 1/4, or there's a 25% change going from 80 to 100, right? Because this is my starting point, and I'm going to change it by 25%, and I'm going to get to 100. With going from 100 to 80, I'm declining by 80, but notice the 20 in the numerator is still the same, but the 100 is different now. The 100 is the basis, not the 80. And so this is 1/5 or 0.2, which is 20%. So it may seem kind of odd to you, but when you increase 80 by 25%, you get 100. If you decrease 100 by 20%, you get 80. Okay, so you have to be really concerned about the basis. What is your starting point? What number are you making the comparison to? All right, so these are the statements. Increase 80 by 25% to get 100. Decrease 100 by 20% to get 80. So that's the thing to remember, is what's the base number? Okay, so when we are setting up models that have to do with percentages, this is your general model. It may not be exactly this every time, but you should immediately think about this. You have a compared number is a percentage times a base number. So if it's 80 times 25%, that compared number is 20. So I'm going up from 80, up 25% to 20. So I get 20 is 25% of 80. And when I put in, different values, 125 is 50% of 250. Okay, what number is 8% of 60? Why don't you take a minute and see if you can get that. You should be able to do that without a calculator. Okay, anybody know? Yes. 48. Think about that. 8% is less than 10%, right?
Oh, it's
so
60 minus 48. So.
No, it's not 60 minus 48. Think in terms of this. We have 8% is 0.08, right? So we have 0.08 times 60. So your numerals are right, but the decimal's wrong. So what do you think? Yes? 4.8, okay? So what I started to say about the 10% here is that 8% is a little bit less than 10%. 10% is an easy number to calculate. 10% of 60 is 6. So you would expect 8% to be somewhat less than that. And you know it's going to involve multiplying 8 and a 6. So if you get 8 times 6, you get 48. But it's supposed to be a little bit less than 6, so that's 4.8. There's a way that you can estimate what value you're expecting before you do the computation. It's one of the reasons why I'm not letting you use a calculator here, because I know you all can multiply 0.08 times 60, but I want you to get a feel for the numbers, and so you would expect that 8% of 60 is going to be a little bit less than 6. Okay, so think in terms of estimating your numbers before you're doing your calculation even. Okay, 4.8. Okay, so you answer your question. 42 is, or here's another question. 42 is what percent of 70? You have an answer? 29.4. 29.4. Okay. Anybody else get something? How did you get 29.4?
Multiplied 70 by 42.
Ah, but this is the number. It's not the percentage. We're asking for a percentage, right? You're using 42 as your percentage. Okay. Let's look at how to do this. Okay, so let's put this in our model. We have 42 equals our percentage. Now, I didn't actually define my percent because this is a short example, but p times 70. So I'm going to divide both sides by 70, and I get 42 over 7 is going to be 3/5, which is 60. So 42 is 60% of 70. All right, so if you think, okay, 60% is just a little bit more than half. What's half of 70? Half of 70 is 35. So you're going to expect that 60% is going to be a little bit more than 35, and indeed 42 is. So you get, there again, kind of a number sense. Now, most of you would probably reach for your calculator, and honestly, if I was at my desk, I would too, in simplifying that fraction. But one of the things that I asked you to do last time is to review how to factor, okay? And so you can do these things very quickly and very accurately by factoring. So 42 is, how do we factor 42? That's, first of all, it's 7 times 6, right? Okay, so 6 is 2 times 3 times 7. Okay, that's fully factored. 70 is 2 times 5, which is 10, times 7. Okay, so the 2's cancel and the 7's cancel, and I get 3/5. If I multiply that to make the denominator a 10, what I get is 6/10, and so I know right away that that's going to be 60%. So do your division by factoring when you're simplifying ratios of integers. It's much faster, much more accurate, and you'll develop a sense of confidence and a way to do things in your head that will just amaze your friends and impress your parents, okay? I mean, that's what you do, right? You show everybody your mental prowess and calculations. And you're thinking, this guy's nuts. So, anyway. All right, so let's move on here. 36 is 30% of what number? Okay, before we get to an answer, let's estimate this. Here's a way to do this. 30% is about a third, right? It's not exactly a third, but it's about a third. So we're going to look for a number that's roughly 3 times 36, right? So if 36 is close to 33, 33 times 3 is about 100. So we're going to look for a number that's around 100 to get there. Some number, 30% of some number is going to be 36, and we're going to expect that to be somewhere around 100. So what did anybody get? Anybody get anything? Yes? Sorry? 120. Okay, tell me how you got 120.
36 divided by 3 is 12.
Great. Okay, so you did the math with the numbers and you adjusted your decimal based on your expectation. Okay, great. So you have 36. If I were to do this by my formula up here, I'd have 36 divided by, or equals 0.3n, and so you have 36, and you had divided by 3 because you were going to adjust your decimal differently. You get 360 divided by 3, and we get 120. Okay, so before we go on to ratio problems, if you look on page, in your book, page 59, there's a whole bunch of problems like the last 3 that I just had you do. I'm not going to assign any of those problems for homework, but if you need practice with this, go there. You have the answers in your book to all the odd-numbered problems. This should be something that's pretty second nature to you. You know, if you're going to study science or an economics or something of that sort, percentages are a fact of life, and it's one of those things that you'll be using a lot. Okay, so let's go into ratio problems. This is that second class of problems that we want to talk about. When we talk about proportion, what we're talking about is a statement that equates two ratios. A over B equals C over D. So several things come out of this proportion, that AD equals BC, you call that cross multiplying. Or if you take individual variables here, you can solve for C. A times D divided by B is going to be C. That's that cross multiply and divide thing. Or if you're going to look for D, it's going to be B times C divided by A equals D. Now, finding A and C is a little easier because you just take A equals C times B over D. And if you're trying to find C, it's A times D over B. So you should be able to, once you set up a proportion, to solve for the variable in any of the positions in the numerators and the denominators. Okay, so one of the things that we know about triangles, similar triangles, is that the sides are proportional. Okay, so when we have two triangles that have sides that are proportional to each other, we have similar triangles, meaning that the angles are all the same. So if we look at the ratio of any two sides, it'll be the ratio of the other side. So if we take 4 divided by 3 would be 8 divided by 6, or 5 divided by 3 is going to be 10 divided by 6. So we can take any pair of sides and make ratios of them, and it'll be the same when you have similar triangles. And so I didn't write similar triangles here, but write that in your notes that I'm talking about similar triangles have proportional sides. Okay, so if I have two similar triangles, what is this side? Okay, anybody have an answer here? Yes? 4. How did you get to 4?
I said like 8 over 12 equal to 3
Over x, right? And x was the side that you're looking for. And then you solve for it. Good. Okay. So there's a number of ways. Look, I even used x, the same variable that you did. So there's any number of ways of setting this up so long as you're taking them in the right place. So I think you arranged this a little differently than I did, but it's equally valid where I said, okay, I'm going to take the height of this one divided by its hypotenuse, or what appears to be the hypotenuse, and then I have my x over 12, and so I just solve for it and I get 9/2, right? Is that what you got? No? Okay. All right, here's a proportion problem that's a different sort. It's not geometric, but if you go and buy a gallon of paint, you'll see that, ordinary wall paint, you'll see that most of the time a gallon of paint covers 400 square feet. So you have 2,800 square feet. You calculated that's how much wall space you have to paint. How much paint do I need to do that? Okay, let's talk about how to do this. So the first thing we do, the first step, is make a model. And here we have a proportionality that's true, that the area divided by the volume is going to be some constant. And so I'm going to take what I know, 1 gallon covers 400 square feet. I'm going to define G as the gallons needed to cover 2,800 feet. And so I set up my proportions. 400 over 1 equals 2,800 over G. And so when I solve for G, I get 7. And so I'm going to answer my question. I need 7 gallons of paint. Now, you probably didn't write all this in your notebooks, and it's a very simple problem. In fact, once you've done the problem, once you can start doing these in your head. Okay, but from the standpoint of taking a very simple problem and laying out the process, this is the kind of thing that I want you to do. Okay? Any questions on that one? Did you all arrive at that, basically? Okay, now we have markup and margin. Okay, markup is what is what you use in business to make a profit. Something costs you something, and you want to sell it at something. And so you add a markup to it, and that's going to cover your expenses, your rent and things like that. And it's also going to include your profit. Now, I want to make a distinction between two words here, that from the perspective of a merchant, and all of these things, you're going to have the perspective of a merchant, somebody who's buying and selling things. When you talk about cost, that's what it costs you to get something. When you talk about price, that's the price that you're offering to sell it to somebody else. So we use ordinarily the words interchangeably. When you go into a store with somebody, you say, oh, that's kind of nice. How much does it cost? Oh, the price is $30. And you would say that those two words are used synonymously, and that's okay. But let's be a little bit more precise and refer to cost as what it costs me, the money that I put out to get something. The price is going to be the price that I offer. So in other words, I offer my goods, you give me my price, I give you the cost, okay? So there's your general model. And so the markup that we put, these are all dollars, right? You have this in dollars, that in dollars, that in dollars. Your markup is generally spoken about in a markup rate times the cost. Okay, so if I have something that costs $100 and I'm going to mark it up by 20%, I'm going to take my cost times the 20%, I'm going to mark it up $20. Okay? So that's the general model. And I think that's one. Yeah, I guess I was okay there. Okay, cost is the base. You buy something, add a markup, that determines the price. So let's say Bill has a booth at the farmer's market. He buys bananas at 15 cents each and marks it up 20%. What does he sell it for? Okay, so here's one of these where you're going to look at 15 cents is the price, or 15 cents is the cost, and we're trying to determine the price. So if I do that, I'm going to first define what I know. 15 cents is the cost. 0.2 is the markup rate. The markup is M. M is 15 cents times 0.2, which, when I do my calculation now, is going to be 3 cents. 15 cents plus 3 cents is 18 cents, so he's going to sell them for 18 cents each. So less writing here, but I still have all of these things here. I embed my model, but I certainly define my variables. M is the markup. That's the thing that I would be looking for when I'm looking at your work. And then you lay out your equations and you solve them. You come up with a plain English answer. I don't really care what variable you use. I care about the answer. What does he sell it for? He sells it for 18 cents each. So there's no There's no algebra speak in there at all. You're answering somebody in plain English. Okay, so here's one for you. So a shoe store, it's early, marks up shoes 50%. It buys a certain shoe style at $65 per pair. What is the store's price? Okay, doing okay with these? Saw a lot of writing, so that's a good thing. All right, so in the interest of time, let me just lay this out. Okay, so our model is the price equals the cost plus the markup. The markup equals the markup rate times the cost. And so I'm going to define my variables now. P equals the price, 65 is the cost, 0.5 is the markup rate. And so then I'm going to say my markup is 0.5 times 65. So my markup is $32.50. So my price then is 65 plus $32.50, which is $97.50. And so the answer to the question is the store's price is $97.50. Okay, see all 5 steps. You see what's in purple is here. Defining the variables, P equals the price, and then I have the rest of the constants that I lay out. I write my equations based on my model, I solved my equation, and I answered the question. So you should be able to, if you have this all done right, is to read that question, what's the store's price, answer it directly, the store's price is. Okay? Okay, now let's look at something different. And it sounds the same. And it's just going back to that proportional thing where, you know, increasing something by 25% and then decreasing it by 20%, you'll get to the same, you'll get to your starting point. So margin and markup work the same way. Markup is where you take a price and increase it, or markup is where you take a cost and increase it to a price. The margin is going to be what the difference is between the price and the cost, but you're going to use the price as the basis, not the cost. Okay, when you're determining a price, what you normally do is that you use a markup. Okay, you know what you bought something for, and you want to apply a price to it, so you mark it up. But when you're looking at things and you say, okay, here's the things that I sold this for $100, this for $200, and so on, you're going to want to know how much did you clear your costs by, and so margin is measured from your price, not from your cost. And so an accountant will generally tell you what your margin is more than your markup. Okay, so let's say an accountant tells a business owner his month's sales were $50,000 and he had a 20% margin. What was his cost? Okay, so we'll go through the usual steps. We say, okay, C is my cost, 20% is my margin rate, $50,000 is my sales, which is the price. So M is my margin. 0.2 times 50,000, I had a $10,000 margin. And so 50,000 equals C plus 10,000, 40,000 equals C, so his cost was 40,000. So his margin here was 20%. But his markup now is 10,000 divided by 40,000, which is 25%. So his margin is 20%, his markup is 25%. Okay, so one is the perspective of looking from the cost. Margin is the perspective of looking at the price and seeing how much you've cleared your costs by. Now it's a subtle but important difference. And notice that the margin dollars and the markup dollars are the same. It's just that the rate, the margin rate and the markup rate has a different basis. Okay, and this is just recapping what I said. A markup, how much do you add to the cost to establish price? The margin is how much did you exceed your costs with respect to price? So if I make a distinction here, the cost, markup uses the cost as the base, margin uses the price as the base. And so if I make a graph, let's say if I'm going to sell something here and it costs me this, this amount is both the markup and the margin, but in the rates, they're different. So if I were to say, okay, this is a 20 cents difference. If I'm selling it at 100 and I bought at 80, there's $20 between what I'm buying and what I'm selling for. So my margin is 20 divided by 100, which is 20%, but my markup is 20 over 80. The basis is the cost, so that's 25%. Okay, so it'll take a little bit just to kind of manipulate this and and develop some way to make up what your how you're going to distinguish the two. The markup is probably the easiest one to think about because the markup is how much you're going to bring something up from the price. Okay, so then margin must be the other thing. It must be measured from the price down to the cost. Okay, here's one for you to try. So a store sells a watch for $400. It costs the store $240. What is the margin rate? And what is the markup rate? Okay, so you have to calculate both. Okay, what do you think? So the actual dollars for the margin and markup are the same. It's 400 divided by 200, or minus 240, which is 160. So we added $160 to 240 to get to 400. So the margin rate is the margin divided by the price. and so it's 40 over 100 if you reduce those fractions, or you get 40%. The markup rate, it's the same $160, but you're comparing that to the cost, and so when you simplify this, just factor this. 16 is easy to factor. It's 2 times 2 times 2 times 2 times 10, which is 2 times 5. 240, 24 is easy to factor. That's 2 times 2 times 2 times 3, and then we have 10, which is 2 times 5. And so we have all this factored out. You cancel out all your 2's, and you're left with a 2 in the numerator and a 3 in the denominator, so you have a 66.7% markup rate. So the margin rate is 40%, and the markup is 66.7%. Okay, so the third element in all this price stuff is discount. So if we have a list price and a discount, we get a discounted price. And so the discount is going to be the discount rate times the list price. Now this is the part that gets confusing, because people always want to use the discounted price as what the basis of the rate is. You always, always, always want to use the list price as the basis. Okay, so look at this. Sue bought a book at $12. Off a table it said 25% off. What was the original price? So I did the first step for you by making the model. Now, for you, first define the variables, write the equations, and then solve it. So don't try and just do a single operation of, you know, some operation involving 12 and 0.25. Okay, how do we do this? Does anybody want to kind of walk through the whole process here? Be bold and lay it all out there? No volunteers?
Can we check to see if our answer is correct
Yeah,
first?
tell me what you think the answer is.
$15.
$15?
Yes.
So if I take a fourth of $15 off of $15, I should get to 12?
Hopefully.
Hopefully, okay. I don't think so, because a fourth of $15 is going to involve some change. And so to go from 15 to 12, you're going to, you need a whole dollar amount. Okay, so let's just go through this. So the first thing is we're going to define P as the list price. 0.25P right here is going to be the discount. And so we're going to take P minus 0.25P equals the discounted price. And so now that I've defined all that, I can make my equation, and I get P minus 0.25P equals 12. 1 minus 0.25 is 0.75P equals 12. And so we get P equals 12 divided by 0.75. And so I'm going to carry this to the next page here. This looks like ugly math that you want to reach for your calculator, but think about it a little bit more carefully, where this is 12 divided by 0.75 is 3/4. When you're dividing by a fraction, you're multiplying by the reciprocal. And so you get 12 times 4. Factor the 12 into 3 times 4 times 4. And then you have a 3 here. The 3's cancel, and so you get 4 times 4 is 16. So without reaching for a calculator, you can get 12 divided by 3/4 is 16. So the original price of the book was $16. Now let's check this. Okay, so if we're going to take 25% off of 16, so 1/4 of 16 is $4, and so we're going to take $4 off of 16. 16 minus 4 is 12. Okay, so then going the other way, where you're calculating 25% of 12, which is 3, and adding the 3 to the 12 is not the right way. The discount is always taken from the list price, not from the discounted price. Okay, do you see the difference there? It's a very important distinction. Okay, so then tomorrow you're going to have your first tutorial, and what you're going to cover are a couple more type of word problems. One of them is going to be the what's called the mixture problem, and the other one is going to be called the work rate problem. And then for homework that's due on Friday, you're going to have about 4 word problems, which doesn't sound like a large amount, but I want you to concentrate on doing this, and you're going to be graded on how well you can lay it out. So the important thing is just gather everything about the problem in step 1. Step 2 is really the crucial one, is define your variables before you write up your equations that will solve the problems, and then make sure you answer the question. Okay? Everybody wants to jump right to 4 right away and just do a calculation. And that's not what I'm looking for. I'm looking for a really well laid out, use ample space on your paper to go through this. Now with the mixture problem,